In this video, we take a look at the types of errors that come up during hypothesis testing. There are two types of errors in hypothesis testing, the false negative and the false positive. The diagram below explains the types of errors possible. So in our columns, we have the two possible truths. The first column corresponds with the null hypothesis being true, and the second column corresponds with the alternative hypothesis being true. In the rows, we have the two conclusions that we could make as investigators. We could reject the null hypothesis, or we could keep the null hypothesis. Keeping the null hypothesis is what we refer to as failing to reject the null hypothesis. We're stuck with it. We don't have enough evidence. So if we reject the null hypothesis, but the null hypothesis is actually true, what we see in this first box here, that would be an error. So we call that a type 1 error or a false positive, because we're going with the alternative hypothesis falsely. If we continue on in that row, if we reject the null hypothesis when HA is true in the second box of the first row, that would be a correct conclusion. The other row, the other possibility, is that we keep the null hypothesis. So in the bottom row first box, if we keep the null hypothesis when the null hypothesis is true, that would be a correct conclusion. If we keep the null hypothesis when the alternative hypothesis is true, bottom row, second box, that's another type of error. That's what we call a type 2 error, or more commonly a false negative. So we're not accepting the alternative when it is in fact true. So these are the 4 different possibilities, 2 ways we can be correct, and 2 different ways we can make errors. A company markets a computerized medical diagnostic program used to evaluate thousands of people. The program scans the results of routine medical tests, pulse rate, blood tests, etc., and refers the case to a doctor if there's evidence of a medical problem. The hypotheses that the computer program is testing are null hypothesis, no change, the medical tests show no difference from the normal levels, or the person is healthy. Alternative hypothesis, H sub A, medical tests show some difference from normal levels, or we'd say that the person is not healthy. So question A asks us to think about what are the 2 types of error that the computer program can make. Describe the 2 types of error in terms of false positive and false negative. The type 1 error, also known as a false positive, is when the person is healthy, but the computer program says the tests show some difference from the normal level. The type 2 error, known as a false negative, is where the person is not healthy, but the computer program says the test shows no difference from the normal levels. So 2 different ways that we can be wrong in the hypothesis testing scenario. Question B. The computer program can be adjusted to decrease one error probability, type 1 or type 2, at the cost of increasing the other error probability, type 2 or type 1. From a public health perspective, which error probability should you choose to make smaller? Explain your reasoning. So a type 2 error or false negative is of more concern since a person is not healthy and could infect people or get more sick. So we would choose to make the type 2 error smaller. So anytime they're working on some sort of test, whether it's a test for coronavirus or a test for some other disease, typically the medical industry tries to make the type 2 error small so that you don't have people who are sick or not healthy out there in the general public. So when designing a hypothesis test and selecting the significance level, we use the symbol alpha, the Greek letter A, to stand in for significance level. The significance level should reflect the consequence of the possible errors. So if making a type 1 error, a false positive, is dangerous or especially costly, so that would be the scenario where the null hypothesis is true, but we rejected it, so we want to reject the null hypothesis less often in this first scenario. We should choose a small significance level, something like 1%. So we'd say alpha, our significance level, equals 0.01. Under this scenario, we want to be very cautious about rejecting the null hypothesis. So we demand very strong evidence favoring the alternative hypothesis before we reject the null hypothesis. If making a type 2 error, a false negative, is relatively more dangerous or much more costly than a type 1 error, then we should choose a higher significance level. For example, alpha equals 0.10, so that would be at 10% significance level. Here we want to be cautious about failing to reject the null hypothesis when the null is actually false. So question C asks us, what is an appropriate significance level for the computer program hypothesis test? Explain your reasoning. For the computer program test, we think the type 2 error, the false negative, is more dangerous. We should choose a higher significance level, such as alpha equals 0.10, so that we don't fail to reject the null hypothesis as often. With the higher significance level, alpha equals 0.10, you will be more likely to reject the null hypothesis and tell the person they are not healthy. So what this means for a medical test is more people will be flagged as not healthy when they're actually healthy. And that's better because then people are going to check to see, are they actually not healthy? They might get a second opinion. But you're flagging the people as potentially not healthy instead of letting people who are not healthy think wrongly that they're healthy and go walk the streets. So we'd rather err on the side of flagging people as unhealthy so that then they go get checked or they get a second opinion rather than thinking that they're healthy when they're not.